Hello and welcome to Math Lessons with Linda. Today's topic is the Pythagorean Theorem, which many of you have heard about by name. Let's look and see what it actually means. When you have a right triangle, which is designated kind of like a little box where the right angle is, there is a formula that you can use to help you find any of the three missing sides. I'm going to show you how it works first, and then we're going to try some. Let's suppose that we have a triangle, and the sides of the triangle are 3, 4, and 5. The Pythagorean theorem says that if I take the length of one of the legs and square it, and then add to that the length of the other leg squared, that should equal the length of the hypotenuse. The hypotenuse is the longest side, and that's squared. Normally we don't write it leg squared plus leg squared equals hypotenuse squared. We assign variables for each of the sides. So you'll see a lowercase a for one of the legs, a lowercase b for the other leg, and a lowercase c for the hypotenuse. So the formula you've probably seen is a squared plus b squared equals c squared. This is what we use to substitute in the values that we know to see if we can find a missing side. For this triangle that we have that has 3, 4, 5, we're just going to verify that it actually is a right triangle. And if it is, then when we substitute in all three of those values, we should get equal numbers on both sides. So I'm going to take the 3 and square it, plus the 4 and square that, and that should be equal to the 5 squared. So if you have a calculator, you're welcome to use that. If you know your perfect squares, then that's great too. So 3 squared is 9, 4 squared is 16, and 5 squared is 25. If I add 9 plus 16, I do get 25, and that equals to 25. So what I've just verified is that the triangle that we started off with is indeed a right triangle because this formula turns out with 2 equal sides. So let's talk about a different triangle and see if we can find one of the missing sides. So let's draw a right triangle. Pictures are always a good idea when you can do one. So let's start off where we have a side that is a length 5 and a length 12. These are the legs. And we have to find the C, which is the hypotenuse. That's the longest side. We're going to plug into our formula. I'll rewrite that. And we are going to solve for the C. So I'm going to let the A be the 5, and I'll let the B equal 12. So I will have 5 squared plus 12 squared, and that's going to equal my C squared. We just did 5 squared a minute ago, which is 25. 12 squared is 144, and that equals to C squared. All I have to do is just add these two values together. And when I add that, I'm going to get 169, and that equals to C squared. Now, you should already have some knowledge of squareds and radicals. If I have something squared and I need to solve just for the C, to undo that, I take the square root of both sides. So the square root of something squared is just that value. So the C comes out by itself. And it turns out that 169 is a perfect square, and I get 13. So what that tells me is that the length of the hypotenuse of my triangle is 13. So let's try one that's a little bit different. Let's suppose that I have a right triangle, and for this one, I know that A is 15, and I know that C is 17, but I don't know B. So So this time I'm going to have to find one of the legs. So I'm going to have A here, C is here. So I'm going to have 15 squared plus the B squared, this time I don't know, equals 17 squared. So 15 squared is 225, and 17 squared is 289. Now this time, to solve for the B, I'm going to have to move this 225. So I'm going to subtract 225 from both sides of my equation. So now I have B squared, and when I subtract over here, I'm going to get 64. So now my step here is the same last step in the previous problem. I've got to take the square root of both sides. So the square root of B squared is just B, and the square root of 64 is 8. So that tells me that the length of my other side, that's a leg of my right triangle, is 8. And those are a few examples of how you can solve for missing parts of a right triangle using the Pythagorean theorem.